Hello, welcome back to my channel. This is Karina living Lean Six Sigma, where I live, breathe, do continuous improvement, and we are going to be on part 3 for our oral and practical on the airframe side. Now, before we get started, if you like what I do, please send me a thank you coffee of some sort. I really appreciate it. I kind of need it. So yeah, please do that. All right, so we're going to start off with section Cabin Atmosphere Control Systems. Question: what are the two main gases that make up our atmosphere? Can you guess? Nitrogen and oxygen. Next, why are the cabins of most turbine-powered aircraft pressurized? Answer: these aircraft fly at such high altitudes that supplemental oxygen would be needed for the occupants if the cabins were not pressurized. Question: where does the pressurized air come from on most turbine-powered aircraft? Answer: from air bled from one of the engine compressors. Question: where does the pressurizing air come from on most of smaller reciprocating engine powered aircraft? Answer: this was a trick question. From the engine turbocharger. Question: what determines the amount of pressurization that an aircraft can use? Answer: the structural strength of the aircraft cabin. Question: how is cabin pressure controlled in a pressurized aircraft? Answer: more pressure than is needed is pumped into the aircraft cabin, and the pressure controller modulates the outflow valve to maintain the correct pressure in the cabin. Question: what is meant by the isobaric mode of cabin pressurization? Answer: the isobaric mode of cabin pressurization is the mode that keeps the cabin altitude constant as the aircraft changes its flight altitude. Question: what is meant by the constant differential mode of cabin pressurization? Answer: after the pressure in the aircraft cabin reaches the maximum value that is allowed by structural considerations, the constant differential mode of operation is the mode that holds the pressure inside the cabin at a constant amount above the outside air pressure. Question: what is the function of the cabin outflow valve on a pressurized aircraft? Answer: the cabin outflow valve, which is controlled by the pressure controller, maintains the correct amount of pressure inside the cabin. Question: what is the function of the cabin pressure safety valve on a pressurized aircraft? Safety valve. Answer: the cabin pressure safety valve prevents cabin pressure from exceeding the maximum allowable differential pressure. Question: why must pressurized aircraft have a negative pressure relief valve? Answer: the structure of an aircraft cabin is not designed to tolerate the inside pressure being lower than the outside pressure. Think about that. If the inside pressure is lower than the outside pressure, okay, that submarine incident that happened, the outside pressure was greater. What keeps the cabin of a pressurized aircraft from being pressurized when the aircraft is on the ground? Answer: weight on wheels, a squat switch on the landing gear holding the safety valve open when the aircraft is on the ground. Okay. Squat, like sumo squat. Question: what are two types of air conditioning systems that may be installed on an aircraft? Answer: air cycle systems and vapor cycle systems. Question: where does the warm air come from that is used to heat the cabin of a large jet transport aircraft? Answer, warm engine compressor bleed air. Question, where does the warm air come from that is used to heat the cabin of most small single engine reciprocating engine powered aircraft? Answer, from a shroud around the engine muffler. Question, where does the fuel come from that is used in an aircraft combustion heater? Answer, from the aircraft fuel tanks. Question, what happens to a combustion heater if the flow of ventilating air is restricted? Answer, if the ventilating air is restricted and the temperature reaches a preset value, the limit switch will cause the fuel to be shut off to the heater. Question, how is the heat removed from an aircraft cabin with a vapor cycle air conditioning system? Remove heat. Okay. Answer, the cabin heat is absorbed by the refrigerant in the evaporator, and it is carried outside the aircraft where it is given up to the outside air in the condenser. Question, what produces the cool air in a vapor cycle air conditioning system? Answer, warm cabin air is blown across the evaporator where its heat is transferred into the refrigerant. It's like a heat exchanger cooling system. The air that leaves the evaporator is cool. Question, why must air cycle air conditioning systems incorporate a water separator? Answer, the rapid cooling of air in the expansion turbine causes moisture to condense in and make fog. This moisture is trapped in the moisture separator before the air is released in the cabin. Question, what is used as the refrigerant in a vapor cycle air conditioning system? Answer, a Freon type liquid refrigerant known as refrigerant 12, or the more environmentally friendly R134A as in alpha. Question, what are 3 ways supplemental oxygen can be carried in an aircraft? Answer, as a high pressured gas, in its liquid form, and as a solid in the form of a chemical candle. Question, what kind of gaseous oxygen must be used to service an aircraft oxygen system? Answer, only aviators breathing oxygen. Hospital oxygen and welding oxygen contain too much moisture to be used. Question, what is used to check an oxygen system for leaks? Answer, a special leak detector liquid that is a form of non-oily soap. Question, what is continuous flow oxygen system? Answer, an oxygen system that continuously flows a metered amount of oxygen into the mask. Question, what is a pressure demand oxygen system? Answer, an oxygen system that flows oxygen to the mask only when the wearer of the mask inhales. Probably there's a flap there. Question, what identification must be stamped on an oxygen bottle that is carried into an aircraft? Answer, the identification DOT, Department of Transportation 3AA or 3 Alpha Alpha, or DOT 3HT 3 Hotel Tango, the date of manufacture, and the date of all of the hydrostatic tests. So identification, the date of manufacture, and the date of all of the hydrostatic tests. Next section, practical projects. All right, number 1, on an aircraft specified by the examiner, locate and identify the compressor, the condenser, the evaporator, and the service valve of a vapor cycle air conditioning system. Find those and point them out. Number 2, on a pressurized aircraft specified by the examiner, locate and identify the source of pressurizing air, the cabin outflow valve, the cabin pressure safety valve, and the cabin pressure controller. So essentially, point and identify the anatomy of this system. Number 3, explain to the examiner the correct way to service a vapor cycle air conditioning system with refrigerant. Next, explain to the examiner the correct way to check a vapor cycle air conditioning system for leaks. Next, demonstrate to the examiner the correct way to check an oxygen system for leaks. Next, purge an oxygen system to remove all traces of air from the lines. Next, service an oxygen system with the proper type and amount of oxygen. Next, check the oxygen bottle in an aircraft for the required identification marks and for the status of their hydrostatic tests. Man, that's going to be a gotcha right there. Next, on an aircraft specified by the examiner, locate and identify the combustion heater, the fuel strainer, the fuel valve, and the thermostat. Last, inspect for leaks in the portion of the engine exhaust system that supplies heat for the aircraft's cabin heater. Instrument systems. Question: what instruments in an aircraft are connected to the static system? Answer: the airspeed indicator, the vertical speed indicator, and the altimeter. Question: what type of repairs or alterations can a certified A&P mechanic make to aircraft instruments? Answer: none. All repairs and alterations must be made by the instrument manufacturer or by an FAA approved repair station certified for the particular instrument. Question: what is the significance of a red radial line on a dial of an aircraft instrument? Answer: a red radial line marks a never exceed condition. Question: what is the significance of a yellow arc on the dial of an aircraft instrument? Answer: a yellow arc marks a caution range of operation. Next, what is the significance of a green arc on the dial of an aircraft instrument? A green arc indicates the normal range of operation. Question: what is the significance of a white arc on the dial of an airspeed indicator? Answer: a white arc on an airspeed indicator indicates the airspeeds at which the flaps may be lowered. Question: what is used to warn a mechanic that the glass on the aircraft instrument that contains the range marks has slipped? Answer: a white slippage mark that extends across the lower part of the instrument cover glass and the instrument case bezel shows whether or not the glass has slipped. A slipped glass would put the range marks over the incorrect numbers. So just like how you put a line indicator over like your screw, same thing, over the glass onto the bezel, and then if it slips, it's no longer aligned. Don't overthink it. Question: where can a mechanic find the range markings that are required on the instrument in a particular aircraft? Answer: the TCDS, Type Certificate Data Sheet of the aircraft. Question: what check must be made if a mechanic replaces any instrument that is connected to the instrument static system? Answer: the static system must be checked for leaks. Question: why are many of the electrical instruments mounted in steel cases? Answer: a steel case concentrates the flux produced by magnetism, in the instrument and keeps it from affecting other nearby instruments. It's kind of like a Faraday cage. It keeps everything. Question: why must an aircraft instrument panel be electrically bonded to the primary aircraft structure? Answer: the bonding straps carry the return current from the instrument into the aircraft structure. Grounding. What? That's just say grounding. Question: what error is corrected when an aircraft compass is swung? Answer: deviation error. Question: what fluid is used in an aircraft magnetic compass? Answer: a special water clear fluid that is similar to kerosene. Question: what is the maximum amount of deviation error that is allowed when a magnetic compass is installed in an aircraft? Answer: 10 degrees. 10 degrees. Question: what is the maximum amount of leakage that is allowed when checking the static system of an aircraft that is operated under the instrument flight rules, IFRs? Answer: for an unpressurized aircraft, the system is checked with a 1,000-foot indication on the altimeter. It must not leak more than 100 feet in 1 minute. For a pressurized aircraft, the system is checked at the maximum certified pressure differential of the cabin. It must not leak in 1 minute more than 2% of the equivalent altitude of the maximum differential pressure, or 100 feet, whichever is greater. Question: why must the length of the thermocouple leads not be altered when installing a cylinder head temperature indicator? Answer: an instrument operated by a thermocouple is a current measuring device. The resistance of the thermocouple and its leads must be kept at the value specified for that indicator. Question: what should a manifold pressure gauge read when the engine is not operating? Answer: it should read the existing barometric pressure. Question: what's the difference between a 2-minute and a 4-minute turn and slip indicator? A 2-minute turn indicator gives a 1 needle width deflection for a standard rate of turn, which is 3 degrees per second. A 4-minute turn indicator gives a 1 needle width deflection for a half standard rate of turn. 1 to 1.5 degrees. Are you saying 1.5 degrees? I don't understand this. I think it's indicating 1.5 degrees per second. I could be wrong. A 4-minute turn indicator has doghouse shaped marks located 2 needles width away from the center mark. When the needle is lined up with the doghouse, the aircraft is making a standard rate turn. Question: what is the difference between a turn and slip indicator and a turn coordinator? Okay, answer: a turn and slip indicator is sensitive about only the yaw, pitch, roll, yaw, okay, so the vertical axis of the aircraft. A turn coordinator uses the canted gyro, which makes it sensitive about both the roll and yaw axis. Okay. Question: what is used as the sensor in the fuel tank for an electric type fuel quantity indicating system? Answer: tubular capacitors, which extend across the fuel tank from top to bottom. Question: why is a dual tachometer used on a single engine helicopter? Answer: one needle indicates the speed of the engine and the other indicates the speed of the main rotor. When the needles are married, the clutch is not slipping and the rotor is solidly engaged in the engine. Question: in what units is the tachometer used on a turbine engine calibrated? Answer: in percentage of the takeoff RPM. In percentage of the takeoff RPM. Question: what kind of system is used to measure the exhaust gas temperature of a turbine engine? Answer: an averaging system made up of a series of thermocouples arranged around the inside of the exhaust duct of the engine. Okay, in series, inside the exhaust duct, thermocouples. Question: what would likely cause the needle of an electrical oil temperature gauge to peg on the high side of the instrumental dial? Answer: there is probably an open in the bulb circuit that is causing the instrument to see an infinite resistance. Just an open. The higher the resistance of the bulb circuit, the further the needle moves across the dial. Question: what is used as a flow meter for most of the small horizontally opposed fuel-injected aircraft engines? Answer: a pressure gauge that measures the pressure drop across the injector nozzles. Question: what two sources of power are used to operate the gyro instrument in an aircraft? Answer: they may be air operated either by a suction or pressure, or they may be electrically operated. All right, we're moving to the next section, practical projects. Number 1, determine from the proper source what range markings are required on the instruments of an aircraft specified by the examiner, and then determine whether or not the instruments are properly marked. Next, remove and properly reinstall an instrument from the panel of an aircraft. Next, perform a static system check on the aircraft specified. Determine the proper source if the system meets the requirements for flight under the IFR, or Instrument Flight Rules. Next, swing an aircraft compass. Properly prepare and install a compass correction card. Question: install the proper range markings on glass of an aircraft instrument. Install the proper range markings. So that is a modification you can make. Question: using an altimeter to find the existing barometric pressure. Check a manifold pressure gauge to determine whether or not its pointers are set correctly. Next, prepare a gyro instrument for shipping. Question: check the pitot heater to determine whether or not it is functioning properly. Question: locate and identify the components in an exhaust gas temperature indicating system. Next, explain to the examiner the proper precautions that should be taken when removing a thermocouple type cylinder head temperature indicator from an instrument panel. It's all these hyphens, sorry, it's just like the words are hyphened at the end, so I have to start the word and then finish the word. All right, next section. For oral and practical, we have the oral section, communication and navigation systems. Question: is a certificated airframe mechanic allowed to adjust a communications transmitter?
No.
Answer: no. This requires a license issued by the FCC, Federal Communications Commission. Question: which frequency band is used for most aircraft communication? Answer: VHF between 30 and 300 megahertz. VHF, very high frequency band, 30 to 300 megahertz. We have to know the units. Question: in which frequency band does the VOR equipment operate? Answer: VHF between 108 and 117.95, say it with me, megahertz. Next, what is the preferred location for a VOR antenna on an airplane? Answer, on top of the aircraft along the center line of the fuselage. Yeah. Which component of the instrument landing system, ILS, shares the antenna with the VOR? Answer, the ILS localizer. Question, in what frequency band does the DME equipment operate? Answer, in the UHF band between 962 and 1024, say it with me, megahertz, and between, this is the second option, and between 1151 and 1213, say it with me, megahertz. All right, so if we're going to pop out numbers, 962-1024 and between 1151 to 1213. You can make a jingle out of it. Well, however you need to do it to remember these numbers. UHF, okay? Question, what is the preferred location for a DME antenna? Answer, along the center line of the belly of the aircraft as far from any other antenna as is practical. Question, on what frequency is the marker beacon signal transmitted? Answer, 75 megahertz. Question, what do the 3 marker beacon lights indicate to the pilot? Answer, blue light indicates passage over the outer markings of an ILS, instrument landing system, approach. Amber means passage over the middle marker, and then white is passage over any other location specified on the instrument approach. Question, what precautions should be observed when working around aircraft radar? Answer, the pulses of electrical energy transmitted from a radar antenna are strong enough that can seriously injure a person struck by them. They can be reflected from a nearby building and returned with enough power to destroy the receiver circuitry. For this reason, aircraft radar should never be operated when there are people or buildings within 100 yards of the antenna sweep. Just do it outside. Don't even do it in the hangar. And then it says, and it must not be operated when the aircraft is being fueled or defueled. Yeah, you don't want to send some sparks to some fuel tank that's being grounded by an operator. Just no, not a good idea. Question, which frequency band is used for long-range communication from an aircraft? Answer, the high frequency band. This might be a trick question. Long-range communication, high frequency band. And this is between 2 and 25 megahertz. Question, what is meant by a transceiver? Answer, a piece of radio communication equipment in which all of the circuits for the receiver and the transmitter are both contained in one housing. Question, on what 2 frequencies does the ELT, emergency locator transmitter, operate? Answer, 121.5 and 243 megahertz. Question, where is the ELT transmitter normally located on an aircraft? Answer, in the tail of the aircraft as far as possible, so it will be least likely to be damaged in the crash. Next question, what 3 components of an instrument landing system, ILS, are installed in an aircraft? Answer, the receiver for the localizer, the glide slope, and the marker beacons. Very good. Question, what kind of antenna is used for VHF communication? Answer, a vertically polarized whip antenna. Question, what kind of antenna is used for the ATC transponder? Air traffic control transponder. Answer, a UHF stub antenna. This is a trick question. Question, What is the preferred location for the ATC transponder antenna? Answer: on the center line of the belly of the aircraft, as far from any other antenna as practical. Question: what kind of conductor is used to connect a VHF or UHF antenna to its receiver or transmitter? Say it with me. What kind of cable? Coax cable. All right, next question. What two types of antenna are used most with ADF receivers? A directional loop antenna and a non-directional sense antenna. I hope what I'm telling you is correct. Please correct me if I'm wrong in the comment section below. Question: why is it important that all shock-mounted electronic equipment be connected to the aircraft structure with a bonding braid? Answer: the bonding braid is used to carry the return current from the equipment. Grounding. Question: why is it necessary to install a doubler on the inside of the aircraft skin when antenna is mounted on the skin? Answer: the doubler reinforces the skin so wind loads on the antenna will not cause the skin to flex and crack. Next section is going to be practical. All right, number 1, locate and identify the antenna for the VOR, the DME, and the ATC transponder. Don't forget the ADF and the glide slope and the VHF communication equipment. You have to know what those acronyms mean, and you have to point them out. Next, locate the static discharge wicks on an aircraft and explain their function to the examiner. Isn't it in the name, static discharge? Okay. Question: inspect the battery of the ELT and determine when it must be replaced. Next, demonstrate to the examiner the way to determine that the ELT, emergency locator transmitter, is not transmitting. Next, demonstrate to the examiner the correct way to check the ELT for operation. Next, locate and check the condition of the bonding braid that is used to provide a ground for some pieces of electronic equipment. Next, demonstrate to the examiner the correct way to check the accuracy of VOR equipment using a VOT signal. Next, demonstrate to the examiner the way to determine the functioning of a ADF system. Gosh, I gotta look these up now. All right, hold on. We're doing this. Very high frequency omnidirectional range. VOR, very high frequency omnidirectional range. Automatic direction finder. Automatic direction finder, ADF. VOT is an approved VOR test signal. Okay, so demonstrate to the examiner the correct way to check the accuracy of a VOR equipment using the VOT signal. Next, demonstrate to the examiner the way to determine the function of the ADF system. Next, check all of the antenna on the aircraft for security of mounting. Next, properly install a BNC connector on a piece of coax cable. Next, locate and identify to the examiner the servos that are used in an autopilot system. Next, check the installation of the avionics equipment in an aircraft to determine the condition of its mounting, the electrical connections, the antenna, and the ventilation and cooling provisions. And last, check the shock mounts on a piece of avionics equipment to determine their condition and whether or not they allow the equipment to strike any adjacent components or structure. Next section, fuel systems, typical oral questions. Number 1, what are 2 reasons PRIST, P-R-I-S-T, is added to the fuel that is used in a turbojet aircraft? Answer, PRIST is a biocidal agent that 1, kills the scum forming bacteria in the fuel tank, and 2, acts as an antifreeze agent, lowering the freezing point of the entrained water that is released from the fuel. Question, what are 2 types of fuel cells that are used in modern aircraft? Answer, integral fuel cells, cells that are sealed off portions of the structure, and bladder type cells. Question, why are fuel tanks divided into compartments or have baffles installed on them? Answer, the compartments or baffles keep the fuel from surging back and forth or sloshing back and forth as the aircraft changes its altitude in flight. Question, what is meant by an integral fuel cell? Answer, a part of the structure in which all of the seams and joints are sealed so they will be fuel tight. The structure itself then becomes the fuel tank. Question, where are fuel system strainers located? Answer, one strainer is located in the outlet of the tank, and the main strainer is located in the fuel line between the outlet of the fuel tank and the inlet of the fuel metering device. Question, what are 3 uses of a centrifugal booster pump that is installed in an aircraft fuel tank? Answer, booster pumps are used to produce fuel pressure for starting the engine, to keep the fuel from vapor locking at high altitudes, and to transfer fuel from one tank to another. Question, what is meant by a compensated engine-driven fuel pump? Engine-driven fuel pump. Answer, an engine-driven fuel pump whose pressure relief valve is acted upon by the pressure of the atmosphere. A compensated pump varies its outlet fuel pressure so that it will stay at a constant amount higher than the pressure of the air that is entering the carburetor. Question, why do engine-driven fuel pumps have a bypass valve in them? Answer, the bypass valve allows fuel from the booster pump to flow around the engine-driven pump mechanism for starting the engine, and to supply the engine with fuel if the engine-driven pump should fail. So it's a backup. Question, why must an aircraft fuel valve have a detent in its operating mechanisms? The detent gives the pilot a positive indication by feel when the selector valve is in the full on and full off position. Question, what characteristics of the fuel is measured when the mass flow fuel flow meter that is used with turbine engine aircraft? Answer, the density of the fuel. Question, what is used as a flow meter for a fuel injected, horizontally opposed aircraft engine? Answer, a pressure gauge that measures the pressure drop across the injector nozzles in the engine. Question, what is meant by a cross-feed system in an aircraft fuel system? A cross-feed system allows fuel from any tank to flow into any engine. Question, why do some aircraft have provisions for jettisoning fuel in flight? Answer, aircraft that are certificated with a higher takeoff weight than their allowable landing weight must have provisions for jettisoning fuel. This allows enough fuel to be dumped to bring the weight down to that allowable for landing weight in case of emergency occurs before this amount of fuel could be burned off through flight. Question, what must be done to a welded fuel tank before it can be repaired by welding? Answer, blow it up. No. Answer, all of the fuel vapors must be purged by flowing live steam throughout the tank, by soaking it in boiling water, or by chemically neutralizing the fumes. All right, we're still on fuel systems. Oral question. What safety precautions must be taken before a person enters the fuel cell of a large aircraft? Answer, the cell must be thoroughly purged of all fumes. The person entering the cell must wear proper safety equipment, most likely a bunny suit, mask, and there must be a person standing by on the outside of the cell. Question, what is meant by a single point fueling system? Answer, a pressure fueling system in which the fuel is pumped into the aircraft through an underwing fueling port. Okay. The fuel flows into the manifold and then into the correct fuel tanks as selected at the fueling station. Question, what gas is used to purge a fuel tank of all fuel vapors? You have two choices. You can use carbon dioxide or nitrogen. Question, why do turbojet aircraft normally have fuel temperature indicators? Answer, because of the low temperatures at which the aircraft operates, it is possible for water to precipitate out of the fuel and freeze on the filter, in the lines, shutting the fuel off to the engines, all of this stuff. The temperature can be kept above freezing by directing it through a fuel heater as needed. Question, how is a fuel leak indicated on a reciprocating engined powered aircraft? Answer, the dye that is in the gasoline stains the area around the leak. Question, what is the purpose of a drip gauge in the fuel tank of a large aircraft? Drip gauge, large aircraft. Answer, the drip gauge allows a mechanic to check the fuel level in a tank from the bottom of the tank. Question, what safety precautions should be taken before an aircraft is defueled? Answer, be sure that the fuel truck is properly located, pointing towards egress, right? The truck and the aircraft are electrically grounded. All electrical power except for what is needed for the defueling operation is turned off. And the fuel is returned to the proper truck or other containers. Don't forget that there's a dead man switch, so the person operating the truck is physically there and holding the switch. That is not a part of the answer, but I'm letting you know that's part of the field. Question, what markings must appear near the filler opening of the fuel tanks on reciprocating engine powered aircraft and on a turbine powered aircraft? So on a reciprocating engine powered aircraft, the word fuel and the minimum grade of fuel has to be there. On a turbine engine powered aircraft, the word fuel and the permissible fuel designations, the maximum permissible fueling supply pressure, and the maximum permissible defueling pressure. So the turbine engine powered aircraft have more requirements, okay? All right, now we're gonna go into practical projects. Number 1, properly identify the fuel in the tank of a reciprocating engine powered aircraft by its color. Remember, we have red, like that bluish green, I think it's blue, clear or wheat color, yeah. Number 2, drain all of the sumps of an aircraft fuel system and check for the presence of water. Next, remove and clean the fuel strainers in an aircraft fueling system. and then reinstall the strainers and check them for leakage. Next, locate and identify the fuel tank probes, the amplifier, and the indicator of an electronic fuel quantity system, and explain to the examiner the correct way to calibrate such a system. Next, inspect the fuel selector valve of an aircraft and determine whether or not there is a positive indication of the valve being fully on and fully off. Next, locate in the proper documentation the correct grade of fuel to be used in an aircraft specified by the examiner. Next, demonstrate to the examiner the correct way to adjust the fuel pressure that is produced by an engine-driven fuel pump. Next, explain to the examiner the correct way of repairing a leak in an integral fuel tank. Next, explain to the examiner the correct way to check a bladder type fuel cell for leakage and the correct way to repair this leakage. Next, demonstrate to the examiner the correct way to use a fuel drip gauge to measure fuel quantity. And last for this section, explain to the examiner the correct procedure to follow if a reciprocating engine-powered aircraft has been fueled with turbine fuel and the engine has been ran. I'm sorry, there's going to be a part 4. All right, we got as far as we could today. Thank you so much for waiting. Again, like and subscribe if you like what I do and you want to thank me. Please send me money. I need to pay my bills. So thank you so much. I'll see you in the next video.